This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 6.3, proving trigonometric identities. Okay, so by the end of this lesson, you should be able to prove identities using other identities. And you should also be able to use the product to sum identities and the sum to product identities to derive other identities. Okay, so when we're proving identities, we have two methods that we can use. The first method is to either start with the left or the right-hand side of the equation and try to work just with that side of the equation to obtain the other side of the equation. So you pick the side that's ugliest and you work with it until you can try and get it to be equal to the opposite side. Your other method is to work with each side separately until you obtain the same expression on both sides. Usually we deal with method 1 where we take the ugly side and we manipulate it until we get the opposite side of the equation. Okay, so let's look at the first example. We want to prove 1 plus sine 2 theta equals sine theta plus cosine theta quantity squared. So again, we're going to start with method 1. We're going to take the uglier side of this equation. We're going to work with it to see if we can obtain the other side. Now, I would say that the right-hand side of this equation is what we're going to work with. And we're going to manipulate this until we can try and get it to equal 1 plus sine 2 theta. So what I'm going to do is I'm going to take this, and since I know it's quantity squared, I'm going to go ahead and multiply it out. Okay, so sine times sine is sine squared theta plus sine theta cosine theta plus sine theta cosine theta plus cosine squared theta. Okay. So I get sine squared theta, and I'm going to bring this cosine squared theta so that it's next to it. Kind of get my terms put together in descending order. And then this becomes 2 sine theta cosine theta. Okay. Now, if we remember and go back and think about our identities, we know we've got one identity that is like our most important identity we're supposed to have memorized. And that's that sine squared theta plus cosine squared theta. You should know that that's the Pythagorean identity, and that equals 1. Okay. Now, I also have 2 sine theta cosine theta. That's another identity. And that identity is 2 sine 2 theta. Sorry about that. Why do I keep doing that? Okay. So now the goal was to get 1 plus 2 sine 2 theta. And what we've done is we have made it so that both sides of this equation are the same. Okay, so we just proved the identity. All right, so let's try another one. Done. Okay, so I think what we'll do is we'll take a look at the right-hand side of this equation and see what we can do about manipulating it. So the first thing that comes to mind is I know that tangent is sine over cosine. So what I'm going to do is I'm going to go ahead and change that over to sine squared x over cosine squared x. Okay. But generally speaking, I don't like to have one fraction and one non-fraction, so I'm going to go ahead and find a common denominator here. And the common denominator for that is going to be cosine squared x. Okay. Which is going to leave me with sine squared x over cosine squared x minus sine squared x cosine squared x over cosine squared x. We can write that as a single fraction. Sine squared x minus sine squared x cosine squared x over cosine squared x. If we look at the numerator of this fraction, notice we have two signs here. So what we can do is we can take out a GCF of sine squared x, which is going to leave me with 1 minus cosine squared x over cosine squared x. Okay. And from the Pythagorean identity, I know that 1 minus cosine squared x is sine squared x. So we get sine squared x times sine squared x over cosine squared x, or sine to the 4th x over cosine squared x. Okay, so I've done a whole lot of work, but I don't seem to have been able to get to the left-hand side of this equation. So what I need to do from here is go ahead and take a peek at this and see if I can't manipulate that to get down to sine to the 4th x over cosine squared x. So let's play around with this. Again, I know that tangent is sine over cosine. Okay. So by adjusting that, what that allows me to do is multiply and get sine to the 4th x over cosine squared x, which, as you see now, is exactly where I want it to go. Okay, so that's method 2, where you do have to adjust both sides of the identity to prove it. Let's move on to example 3. And we're going to prove sine 2x over sine x minus cosine 2x over cosine x equals secant x. Okay, so chances are the side that I'm going to want to look at is this left-hand side. So the first thought that comes to my mind is that I probably want to take these sine 2x's and cosine 2x's and substitute in their identities in order to kind of make some headway here. So sine 2x is a simple one because I know I only have one option for that. 2 sine x cosine x over sine x minus, and cosine 2x, I have 3 options for. I think I'm going to use cosine squared x minus sine squared x. And the reason being is if you look at this side, or this term, we're using both sine and cosine. I'm going to try and keep it consistent. Okay, so what winds up happening here is my sines cancel, and I get 2 cosine x minus this piece, or this term. Oh, goodness. Okay. So now what I'd like to do is get a common denominator, which is going to be cosine. So I can very simply just create this step and make this a squared. Okay. So we change this to one fraction. I get 2 cosine squared x minus cosine squared x minus sine squared x over cosine x. Okay. 2 cosine x minus 1 cosine x is cosine x, cosine squared x. So I get cosine squared x plus, lost my plus sign here. Okay, because we're subtracting, remember you have to distribute the negative through. That's why this became a plus. Okay. And then cosine squared x plus sine squared x, we know is the Pythagorean identity. That's going to equal 1. So I wind up with 1 over cosine x. Okay. So the right-hand side of this equation was secant. We were trying to take the left-hand side and simplify it or manipulate it to equal secant x. 1 over cosine is the reciprocal. So we can go ahead and say that 1 over cosine equals secant. Okay. Or in other words, we have proved our identity, or secant x equals secant x. Okay. Okay. We're going to try one more here, and then we will stop for the day. Okay, so this is the last example we're going to do. We've got secant of t minus 1 divided by t times secant of t, and we want to prove that that equals 1 minus cosine t divided by t. So chances are we're going to want to work with that left-hand side and adjust secant to be 1 over cosine. So that's the first thing we're going to do. So this becomes 1 over cosine of t minus 1 over t divided by secant of t. Okay. So the next thing I want to do is I want to make it so that I have 1 fraction over 1 fraction. So I'm going to find a common denominator, which we know is going to be cosine of t. So 1 minus cosine of t over cosine of t. And that's divided by t over secant of t. Complex fractions, we know that we are going to multiply by the reciprocal of the denominator. Now, we do have a little bit of an issue here because we're dealing with secant. We don't want to be dealing with secant. We should have taken that and made it 1 over cosine. But we can do that from here too, so it's okay. So 1 minus cosine of t over cosine of t times 1 over cosine of t over t. And again, that's complex fraction. We can fix that. Okay. 1 minus cosine of t over cosine of t times, we're going to keep, change, flip, right? Multiply by the reciprocal. It's 1 over t. So we get t cosine of t. Okay, and sometimes when it gets too messy, we just start over. And that's what we're going to do. We're starting this problem over. We're doing it correctly. We just should have taken that secant and put it in at the appropriate time, which would be right here. Okay, my apologies. Okay, so we've got t over secant. I do not want secant. I want 1 over cosine. Okay. So I need to adjust this right from here. Okay. T over 1 times cosine t over 1, right? Keep t over 1 and reciprocal of the denominator. So this becomes t cosine t. This is going to be much easier. Sorry about that, guys. Okay. So 1 minus cosine t over cosine t divided by t cosine t. Again, it's still a complex fraction. So we're going to keep the numerator, multiply by the reciprocal of the denominator. Okay, Mrs. Cucci gets an F for example 4. We are going to start completely over from scratch. I just keep multiplying by the wrong thing and being incredibly silly. Okay, let's try this one more time. My apologies. And if I had editing software, I would edit that whole thing out, but since I don't, you get to see me screwing up. That's okay. Okay, so we're going to change secant t minus 1 over t secant t. We're going to adjust this. We know secant is 1 over cosine of t. I promise I won't mess up this time. Minus 1 over t times 1 over cosine of t. This is where I messed up, right here. Okay, let's fix it. Goodness gracious. Okay, so we are going to take and multiply by this reciprocal. Okay. So we get 1 over cosine t minus 1 times the reciprocal of this right here, cosine of t over t. Goodness gracious. Okay. So what we can do now is we can distribute this through to both terms here. So we get cosine t over t cosine t minus cosine t over t. These will simplify. And I get 1 over t minus cosine of t over t. Or 1 minus cosine t over t. Which, that whole mess ago, is what I was trying to solve for. 1 minus cosine t over t. I apologize. That was awfully silly. I think maybe I need to stop making videos for the day. Okay. Sorry, guys. If you have any questions, which I'm sure at this point you absolutely will, please jot them down. Come prepared to class tomorrow, and we will discuss it. Thanks.